Greater efficiencies, lower costs, endless opportunities to innovate. Digital technologies are said to be transforming the world for the better, but to whose benefit? In the first of a special two-part report, Bob Abeshouse investigates the dark side of the digital revolution and the price we might all have to pay in lost jobs and social inequality.
Silicon Valley, California, home of the most powerful computer and information technology companies in the world. It's the center of a digital revolution promising untold benefits. Technology is evolving faster here than probably anywhere else in the world, but something else is growing quickly too. The gap between rich and poor, inequality.
1 out of 3 families in this community does not make enough to make ends meet.
Ben Field is the executive officer of the South Bay Labor Council.
The Bay Area is one of the fastest growing economies in the country. But what we're seeing now is that most of the benefits are reaching only a very small segment of the population. And of course, this is happening nationwide, not just here, but Silicon Valley is one of the regions where it's happening most intensely and at the fastest rate.
A few months ago, Field and other community leaders launched Silicon Valley Rising, a campaign to reduce housing costs, raise wages, and create new middle-class jobs.
Those who serve the Valley's high-tech giants are barely getting by. So, what we need is to expand economic opportunities so that more people who work for a living can actually make a living. What we've seen with this tech economy is that there are a few jobs being created at the top end, really high-paying, good-quality jobs, and there are quite a few jobs that are being created at the low end, service sector jobs, and the middle-class jobs. Those jobs are actually shrinking.
Nearby San Francisco is also experiencing fallout from the digital revolution. Top wage earners here are pulling away from everyone else at the fastest rate in the U.S. Buses for Google, Facebook, and other companies ferry high-paid tech workers to their jobs in Silicon Valley. This allows tens of thousands to live in the city, fueling popular anger over gentrification and high housing prices that are pushing longtime residents out.
Stop the greed! Stop the lies! Google wants to privatize!
What you see is a few people essentially hoovering up all of the income and all the success, and everyone else kind of struggling. And one of the implications of digital technologies and the internet is that more and more of the economy is coming to look like this.
Martin Ford is a software entrepreneur and author. His new book, The Rise of the Robots, argues that advances in digital technology will wipe out a broad swath of middle-class jobs in the U.S., potentially threatening political and economic stability. Why has digital technology hollowed out middle-class jobs?
The first jobs to be impacted by technology are the most routine jobs. Routine clerical work, for example, or standing on an assembly line. What we're left with are lower skilled jobs that tend to require lots of dexterity and visual perception. And then at the other end, we've got these high skilled jobs that really require advanced cognitive type skills. But I think that what we're seeing over time is that both of those poles are gradually being impacted as well. So it is essentially that hollowed out middle will get bigger and bigger over time.
When you have a hollowing out, it has more people competing for the lower skilled jobs, and that drives down wages too, right?
That's right.
Another problem, he says, is that the successful digital companies of today provide enormous rewards for the few, but few jobs for the many.
Companies are able to leverage digital technologies to just really extraordinary valuations using very few people. For example, Google has, relative to General Motors at its peak employment, about 5% of the number of employees, and yet it's able to generate actually about 20% more earnings. You see that all over. Fears about technology taking away jobs are at least as old as the Luddites in the 19th century.
it's never actually happened. There have been new businesses that have been created, new jobs that have been created.
Right. I do think that this time is different. You know, we have seen major technological disruptions in the past, but the issue today, though, is that this technology is really general purpose. It's everywhere. It's going to invade every sector of the economy. We've never seen machines that could really move into cognitive areas and start competing with people in terms of actual brain power.
This is Jeopardy!
IBM is at the forefront of advances in cognitive computing and machine learning. In 2011, IBM's Watson computer stunned the world by beating 2 champions in the Jeopardy game show.
Now we come to Watson.
Since then, Watson has become even more powerful, and its capabilities are being marketed to a wide range of businesses. Group Vice President John Gordon showed us the Watson Experience Center. So these are different jobs that can potentially utilize Watson.
Yeah, that's right. Think about these professionals, whether it's a medical researcher, someone working in retail. You might have customer service here. We've got an attorney, an HR director. Here's a chef. And these are all different professionals that have expertise, and we want to think about how we can scale them.
Scaling means breaking down analytic skills and judgments into algorithms computers understand, so that human expertise can be learned and widely disseminated. How much information can Watson process?
It's just tremendous. Watson has the ability to look through all of the information, come up with thousands of different possible options of ways to address the problems, and then weigh each of them independently. It's a much broader and more detailed type of analysis than we can do on our own.
IBM markets Watson's ability to learn, both from humans and its own analysis and decision-making.
Machine learning really holds a lot of the opportunity to show how each of these systems can improve with experience. Just like we have more experience as we have more practice, these systems can have millions of examples of practice and build more experience over time. So these screens over here actually let us run live systems connected to Watson. You can see
IBM is working with doctors at the Memorial Sloan Kettering Cancer Center in New York to train Watson. The system will recommend cancer treatments to oncologists around the world.
So this is now letting the physician see the information that it's found about the patient. And here, Watson's now going to compare that to millions of pages of medical information that it can use to see all these potential treatment options, which ones are more likely to be successful and which are less. And for the physician, it not only shows them that information, but it gives them the rationale.
So a lot of applications are being developed like this for different jobs and professions.
Yeah, let's look at a different...
One of Watson's most powerful capabilities is that it can answer questions posed in everyday language.
I can type right in here in the space, what is the relationship between salary and education? And that's a question both you and I know how to ask. It's using very natural language. We did a very simple piece of analysis here to illustrate the point. High school, college, all the way up to doctoral student, you can see how these different degree levels affect salary and income. This is one of the most powerful aspects of the cognitive computing era. We're now letting technology understand us as we use natural language and ask questions the way we would ask another person.
Navigating social services is hard.
Watson's natural language processing capabilities are being used to provide help in a new way.
It provides information on everything from healthcare to food pantries to job assistance and helping you pay your energy bill.
Computer science student Bree Conley led the team at the University of Texas developing Call Scout. The help it offers is currently provided by human operators who man a 211 call center hotline at the local United Way.
Our app does the same thing, but using Watson. So Watson will tell you the services that you need. We can even suggest other services that could help you.
Some 60,000 hotline documents are currently being loaded into Watson. The Call Scout system also learns from the human operators.
It's not just like a robot teaching itself. It takes a lot of expert training from humans. Right now, we're just focusing on 211 hotlines and social service providers here, but this kind of paradigm can be applied to other customer service entities. So things like banks, insurance companies, they all have these call centers.
Kay Garza is the vice president in charge of the 211 call center in Austin. Do you think that the application is going to affect your staffing levels at all?
I don't. I think it will complement what we do. And there's other social service agencies as well as state agencies that are rolling out mobile apps, so I definitely think it can help get the information out.
As this technology cascades across all industries and it gets incorporated everywhere, I mean, I don't think there's any doubt that it's going to impact jobs.
Ford believes that human language processing systems trained for call center work pose one of the most immediate threats to large numbers of workers in the U.S. and the developing world.
In countries like India and like the Philippines, you've got huge numbers of people employed in these offshoring centers. And of course, in the United States, you've still got some jobs here as well. I mean, in the nonprofit sector, it's not going to generally impact people's livelihood, but in the private sector, in the corporate sector, and that's the area where you really see this drive for efficiency. Becoming more efficient is going to mean very often eliminating workers.
You know, there's concern that with machine learning, that once someone gives the machine its expertise, that the human's not needed anymore.
Well, I think what you'll see in all these systems, especially where we're focused all the time, is where the collaboration comes in. Watson's best space and its optimum area to focus on is places where there's more information than any of us have the ability to read or digest.
So with Watson's capabilities, you know, when you're talking about a call center or a service center or selling something over the phone, you don't see any threat to jobs from Watson.
I think right now you're going to see a lot of growth coming out of the new opportunities, the people that get propelled into the market, and the way we're going to empower people to participate in the information economy. That's going to be the major takeaway we're going to see from this cognitive era.
Well, I think for those of us working in machine learning, it's actually vital that we think about what the societal consequences of our work will be.
Michael Osborne is a professor of machine learning and artificial intelligence at Oxford University in England.
At some point, we will develop algorithms that are at least as competent as human beings in almost all tasks. And at that point, it's very difficult to see where jobs might remain, particularly for the low-skilled workers.
Osborne says that what's pushing breakthroughs in machine learning now is cheap computing and access to massive amounts of data. That's what makes Google Translate possible. Even more striking is the recent ability of computers to write articles and reports as well as a human.
You know, it wasn't so long ago that that kind of understanding was seen as something that could never be reproduced in an algorithm. What's changed is the enormous availability of data from the web which describes exactly these kinds of narratives. So an algorithm that's equipped to kind of scrape all this text from the web can dig into the data and identify the common structures to all these different stories and go some way to understanding the kinds of things that come naturally to us as humans.
Leading the way in computer-based authorship is the North Carolina company Automated Insights.
So we've worked in a variety of industries, everything ranging from business intelligence to finance and sports to health and fitness.
Robbie Allen is the company founder and brains behind their Wordsmith writing platform.
So we established a partnership with the Associated Press this past summer where we take earnings data and generate earnings reports.
So your system is actually writing these articles right now?
That's right. Everything you see here in paragraph form is produced by our system. So another one is Wordsmith for Marketing, where we take all sorts of complex metrics and produce a report that's anywhere from 6 to 10 pages long. And the goal of every project is to create content that doesn't sound like it was produced by a computer.
In a blind study, participants could not tell the difference between an article written by a person and one written by Wordsmith. What impact on jobs has your program had in the businesses it's being used in?
So to our knowledge, Wordsmith hasn't been responsible for anyone losing a job, and it's a common question that we get.
There's no question that if your program wasn't there and AP wanted to have these stories anyway, they'd have to hire more people, no?
That's right. Well, but the thing is, it's not cost effective for them to cover 3,000 companies a quarter the good old-fashioned way. You know, the only way they can do that is through automation.
The company promotes Wordsmith's ability to write sophisticated analytic reports for top corporate executives and customized guidance tailored to individual employees. Isn't that what middle-level managers do?
Anybody whose job it is to look at data and, repetitively and try to make decisions or draw insights from that data, those jobs are not ideally suited for people. And so in the future, absolutely, I think those types of jobs will be, taken over largely by software such as Wordsmith. But I don't think that's a bad thing.
White-collar automation is, I think, going to be one of the things that's really disruptive. It's going to happen sort of behind corporate walls and maybe kind of invisible to the public. We see evidence of it already. I mean, there's no doubt that if you look at corporations in the United States, they're getting better and better at doing more with fewer people, and a lot of that has to do with technology.
We found that roughly half of US jobs are automatable over the next decade or two.
Dr. Carl Benedict Frey teamed up with Professor Osborne at Oxford to study the impact of computerization on jobs in the U.S.
And this is not just confined to administrative support or production jobs, which we've seen automated in the past. What we find is that also a lot of jobs in transportation, logistics, services, sales are going to be readily automated as well, or automatable, I should say.
Doesn't your study suggest there could be a massive loss of middle-skill, middle-income jobs?
I think people in some occupations have reason to be concerned. I think people in other occupations may be less so.
So we identified 3 of what we call bottlenecks to computerization, and they are in turn the requirement to perform socially intelligent tasks, creative tasks, and to perform perception and manipulation tasks in unstructured environments. So what these 3 characteristics share is the kind of deep reservoirs of tacit knowledge that humans possess that is difficult to reproduce in code.
Is your study relevant to what's going on in other countries besides the United States?
So our study is, we think, absolutely relevant to the majority of developed nations.
Frey and Osborne see some of the greatest risk of job loss in logistics and the transportation sector.
To occupations like forklift drivers, agricultural vehicle drivers, mining vehicle drivers, all these occupations are already being impacted by technologies derived from autonomous vehicles. So these robots are really not very far away.
Mercedes-Benz has a self-driving truck it aims to get on the road by 2025. Google rolled out its prototype of an autonomous vehicle last December. A key digital technology powering autonomous driving was developed by Velodyne, a Silicon Valley company. It's a laser device that spins on top of a vehicle. Wolfgang Juchmann, Velodyne's marketing director, provided a demonstration of how it works.
So the device is actually on the roof here, right?
Yes. Essentially all the car manufacturers are using it. For example, Ford Motor Company, GM, Bosch has a Toyota. What you see is a 360-degree 3D image of the environment, and then the computer program makes a decision. Is there some object that we need to try to avoid? Do I need to brake? Do I need to accelerate? Whatever is necessary.
The feedback here is almost the speed of light, right?
Yeah, this sensor produces 1.3 million data points per second, and that's used to detect objects and avoid collisions.
This is actually showing you what's in front of you, the signs, the people.
Yeah, on the right-hand side, there's a car pulling up in front of you, so now the computer would have to make a decision. Are we driving too fast to hit that guy, and do we need to slow down, or are we okay?
The light sensor also identifies different signs and objects by their reflective qualities.
So this red line here is actually the center line for the street. For
yes,
the center
exactly,
line.
yes. And you see the bicyclist on the right-hand side here, right there.
Oh, I see. There's the bicyclist.
There's people crossing the street right in front there. That's why everybody's stopping.
I started from what a computer would want to see if a computer was going to drive a car. And so that I worked the math back into the type of image I would need. And as a result, came up with this device to make that image.
David Hall invented Velodyne's laser device and is the company's CEO.
Do you think we're going to see autonomous cars, self-driving cars?
Oh, I guarantee it. They're really not that hard to make. It's really a simple problem. Just stay in your lane and don't hit anything.
When do you think we're going to see autonomous cars?
Well, I think my prediction is we'll have really great hardware in about 5 years.
Some people think that autonomous cars will lead to major disruptions that will reshape the job market. How do you see it?
Having somebody drive a taxi cab is kind of a waste of talent, to be honest with you, because you can have them doing something more intelligent than that. And so what's the value for someone driving a car? It's just wasted time. And, suppose they were busy, productive. So, no, this is all for the better. This is just a tragedy, the way cars run now. It's barbaric, it's stupid, and you just have to reinvent the transportation process.
10 years from now, we'll likely be having self-driving cars and robots doing delivery for us. We won't need human drivers. We won't need human taxi drivers. We won't need human truck drivers. So we wiped out millions of jobs over there. So good that you now have all of these amazing advances, bad that we don't have the jobs.
Vivek Wadhwa is a fellow at the Stanford Law School in Palo Alto. He is also vice president at Singularity University, a think tank and teaching program located on the grounds of NASA's Ames Research Center. It's funded by successful high-tech entrepreneurs and companies like Google, Cisco, and Genentech.
I live two lives. One is at Singularity University, where we look at all these amazing technologies which will impact mankind and allow us to solve the grand challenges of humanity. And then I come here to Stanford to sober down, basically, to realize the fact that along with every good comes a bad, that along with these technologies, we're creating new problems for ourselves.
How are your views about the dark side of the digital revolution received here in Silicon Valley?
They'd rather not deal with it here in Silicon Valley. They'd rather look at the bright side and think about all the good and imagine that they're not responsible for any of the mess that's being created.
Do you think that the dislocations associated with the digital revolution will be as great as the disruptions of the Industrial Revolution?
Bob, without doubt, these dislocations are probably an order of magnitude greater, and they're happening an order of magnitude faster. We would have figured out how to solve the problems of humanity. We will have unlimited clean energy. We would have solved the problems of disease. And the AIs, the artificial intelligence doctors will be better than our doctors are. The good news. And the bad news is that we will need fewer doctors. So we're now going to create unemployment in the medical industry. The same thing happens with manufacturing. The future I see, 15 to 20 years from now, the vast majority of jobs start disappearing.
But it's absolutely no different than when the steam engine came out and people said, oh my God, the steam engine is going to take away, all the jobs. When the car came out and they said, there go all the buggy drivers.
Steve Cousins ran one of the most successful robotics incubators in America.
So somebody at the front desk will get a call from you and you'll say, I want a snack.
Today he heads Savioke, a company that builds robots like this one for the service industry.
They'll come over and type in the room number. Your room number is 333. And now I'm ready to load it. Since you want a whole bag of food, I just put them inside like this. And now it's ready to go. So all I do is say go. And now the robot's off on its own. If we stand here and block its way, it'll find its way around us and find its way to the elevator.
So no one needs to be with it at all the whole way?
No, it's completely unattended at this point. It just called the elevator over wireless. It just called floor 3. So you didn't have to push it and I didn't have to push it. So now it's just getting off.
So how has this worked? It's been mapped out?
Yeah, it has a map of the whole building and it knows where to go.
When the robot gets to the room, it calls the person inside. So if I open the door now, we'll see what happens.
It changes to, here's your delivery. All right, so you can go ahead in and be the recipient. So a little happy noise. You take your bag out, and now you can, it says, please remove your items, and you hit all set.
Okay, I'm heading home.
We've tried to really make it affordable. And hotels, obviously, is where we're starting. Hospitals, elder care, restaurants, office buildings. The robot will be a lot cheaper than if you hired somebody to do that same task. But it's not going to do everything that a person can do. And so what it allows a business to do is to add new services. I have a great imagination. I can imagine it working anywhere.
How would it work in a restaurant?
Well, you think about times when, where's that waitress? I need some salt, I need a ketchup, I need a whatever, right? There's already restaurants today that are starting to put tablets on the table so that you can ask for things. But there's a whole back-end system that has to be there to support that.
There's every reason to believe that machines and robots and so forth and self-service technologies are going to penetrate that more and more.
Ford is particularly concerned about the impact of automation on restaurant and fast food jobs.
It's traditionally been an area where it's relatively easy for people to find a job because there's very high turnover. It's what you might call a job of last resort. It's an extraordinarily competitive business, and so companies are going to be looking for opportunities to cut costs there. Eventually, it's inevitable that we're going to see that, and that could threaten literally millions and millions of jobs.
There's not an easy way to stop, and I don't even think it's desirable to stop progress. I mean, people have been concerned ever since the Luddites. Technology's coming, it's going to take my job. And all the evidence historically is that when we have more technology, actually the number of jobs grows.
This is what everyone says, that look, at the turn of the century we only had, with majority of our jobs were in agriculture. Look, we figured it out. Just because it happened before doesn't mean it'll happen now. We're going to be building all sorts of new robots, all sorts of new technologies. So I see an economic boom in the United States, then I see jobs disappearing. We're fine for the next 10 or 15, maybe 20 years or so. Beyond 20 years, I know we're in trouble, but we have 20 years to figure it out.